Hey everyone, welcome to this video, and in this video we are going to learn about what is network and what are different networking terminologies. Okay, so let's get started with this basics. And first of all, I'll make you understand what is network. Okay, so network is connection between two or more entities. Any network, okay, a network is a connection between two or more entities. So for example, mail as in not email. Okay, like in previous days, and still even, okay, we used to post a postcard, so that's considered as a mail. Why it connects between two people? Because you send a mail to someone and someone receives the letter that you have sent in their mailbox and they open it, right? So it connects you and the recipient. So mail is a bridge between you and the recipient, so that's basically network. Phone system, so of course phone connects between two people and or more than two people as well, right? Rail system, so rail connects between two cities mostly. Highways are also, again, it connects two cities, right? Road, of course, so road connects to destination. So similarly, all these are examples, classical examples of what a network is. So network is not a new thing. We already have a network in a lot of places, but why we are understanding the basics? Because we want to deep dive into the computer network. So what is a computer network? It's basically, a computer network is basically a network between two or more computers. Okay, it's very simple. A computer network is basically a connection between two or more systems, and that's basically a network is. Okay, so as you can read out over here, a computer network is a collection of computing devices that are connected in various ways in order to communicate and share resources. So of course we have a question: why do we network? Okay, why is there a need to connect two computers? Okay, or maybe something, two different entities? Because we always want to share some resources, share some information. Okay, so it's about sharing information, it's about exchanging information, it's about sharing resources or exchanging resources, and that is why people network. Okay, so of course, and that is why computer also networks. We do a lot of stuff when we are connected between, like if two computers are connected, we can do a lot of stuff. Okay, so usually the connections between computers in a network are made using physical wires or cables, and apart from this we also have a wireless connectivity. So there are two ways. A traditional way is basically to connect two systems with the help of cables. We call it as an Ethernet cable or a LAN cable. Okay, and apart from this, now we have a wireless connectivity as well. So we can connect computers with the help of wired network or a wireless network. The why do we network? The main question, the purpose is to share resources, information, files, data, etc. So here is the example. Okay, these are common examples that we do in our day-to-day life. Example number one: a Wi-Fi router at your home, okay, or office creates a network so that you can share internet across multiple devices. Do we do this? Yes. Okay, we have a Wi-Fi at our home, at our office, and what happens? We take a single line of internet connectivity from the internet service provider, and then with the help of a Wi-Fi router we connect like multiple devices. So this is basically a network. Example number two: file sharing over a Xender. So I'm sure that you guys are knowing about Xender application. So this is basically a file sharing application for mobile phones, or between, like, let's say a laptop and a mobile, okay, over a Wi-Fi network. So in order to share anything in a network, you would always require the address, right? So like you cannot connect your friend on Facebook without knowing his Facebook profile address, right? So if you want to connect your Facebook, if you want to connect your friend on a Facebook account, okay, then you need his Facebook profile. Only then you can connect. Similarly, in a computer network, we will require an IP address of our target person, okay, for sharing anything. So that is again what we require when we share files using Xender. We need our target system's IP address, or we can give our IP address to them and they open up our IP address, okay, or vice versa. So that happens, okay. So that is what all about networking is. That's why we network. Another example of a network, okay, like in this we are sharing files, right, in example number 1 and in example number 2. So in example number 1 we are sharing resource. What is resource? Internet. We are sharing internet, okay. We have one point of connectivity and we are sharing it to multiple devices. And in example number 2 we are sharing files. I'll give you another example. So when you do a mobile hotspot, okay, and when you give that hotspot connectivity to your friend, okay, again in that also you are sharing your internet using a mobile phone. That is also a network. Why? Because you open up your Wi-Fi and Bluetooth ports and you allow someone to connect to your particular device and access your internet, okay. So even that is a network. So network is not an old terminology, like it's not a new terminology. Basically it's a very old thing which we usually use in our day-to-day life for a lot of purposes. So I'll walk you through some of the basic networking terminologies in this entire session. The first thing is the generic term, okay, node or host. In networking we consider any computer system as a node or host, okay. Data transfer rate, the speed with which data is moved from one place on a network to another. So yeah, that is what a data transfer rate is. Data transfer rate is a key issue in computer networks, because if the data transfer rate is not proper, you cannot share the data at a good speed. There may be some corruption of the data as well. Then networking terminologies. So from here onwards we will focus on different networking terminologies. So very first thing is client server model. So whenever we want to exchange any information, okay, like if we initiate a connection, then we are a client, okay, and whenever we send anything to a remote person or a recipient, then that recipient who is accepting the connection or who is accepting the resources, okay, or the files which we are sharing, then it is considered as a server. So whenever whosoever, okay, initiates a connection is considered as a client, and whosoever receives something is considered as a server. Again the server will become a client, because if server will respond back to you, then server will be client, and again when you receive the information from server, you will become a server, okay. So that's how the entire engagement is done between client and server for two-way communication, okay, and sharing of different files and different resources. So from client to server it's request, okay, and from server to client is always response. That's client server interaction. So we have different type of servers: file server, web server. So when we say file server, we usually store a lot of files in our file servers, okay. For example, I'll give you a very nice example of this. If you are staying in a hostel, you might have observed this, okay, that like a lot of people download a lot of movies from the hostel Wi-Fi network, okay. And what happens if you do not have a file server? I'm downloading, let's say, Avatar movie, I'm downloading Avenger movie, okay, then you are also downloading the same movie, okay. So if you don't have a file server, then for the same resource we are utilizing internet bandwidth, okay, of our internet connectivity, and we are wasting it. I hope you are getting this, okay. For the same movie, I also want the same movie, you also want the same movie to be downloaded. You are using your system to download, I'm using my system to download. We both are fetching the files from the internet, so we are wasting it. We are wasting the internet bandwidth and we are wasting the data. So in order to prevent this, we create a file server, okay. We used to do this in our hostel. We used to create a file server, we store all the movies in the file server, and whosoever wants movies from that file server, they can fetch it directly from the file server. That is between a local area network, okay. It's a local area network. In that your internet bandwidth does not go away, in that your data does not get consumed, and that's why it helps. So that's an example of a file server. Then we have a web server. So in a web server we usually store our website and web application files, okay. So web server is basically to host your web application files. Maybe it could be your PHP language code, maybe it could be your HTML, CSS, JavaScript. Okay, all the code related to your website or web application will be stored on a web server. Then we have a different types of network. So I'm sure that you guys are knowing about at least the basic thing, LAN, MAN and WAN. Okay, but still, if you're not sure, I'll just walk you through what is LAN, what is MAN and what is WAN. Okay, so LAN is local area network. So for a small organization, okay, if I want to connect it, let's say 50 computers, 100 computers, 250 computers, okay, I'll be connecting it with the help of a LAN network. It is considered as a LAN network. Okay, if I'm connecting a small area of network or small area of computers, okay, in one place, so that's basically a LAN network. Now in LAN we have these three topologies: ring topology, star topology and bus topology. So here are the topologies: ring, star and bus topology. Now take a pause over here and just look at these three topologies and tell me, like, what is the best topology you can think of out of these three: ring, star and bus. Okay, look at the connectivity, how they are connected, and look at the different aspects, like what is the best topology out of all these three. Okay, take a pause in the video and wait and just give answer to yourself. Okay, so I think you must have gone through the topologies. So the best topology over here is bus topology. Okay, the reason is, in ring topology, even see, all of them are interconnected, right? So even if any one particular node gets down, then the entire network will go down. Okay, that's why it is not considered as a best topology. Again, in star topology, if you can see, all these computers, all these nodes are connected to one centralized node. Okay, and this is basically, you can consider, if this goes down, then everything goes down. Again, this is not the best topology. But in case of a bus topology, okay, see, all of them are connected with a single line of connectivity. Okay, but they are all independent. They are not relying on anything. Like, see, at least they are not relying on any particular other node. This is not relying on this node, this is not relying on this node, and likewise. So all the nodes are independent over here. Of course, they are relying on the single point of line, okay, which is connecting all of them, but they are not relying on each other. And that's why if this node goes down, then entire network will not go down. Okay, and this is why this is the best topology. Okay, always bus topology is the best topology. Types of network, again, yeah, we are focusing on LAN, MAN and WAN. So LAN, I told you, it's basically used for setting up a small scale network, maybe 250 computers, 100 computers, 50 computers, okay, at one premise. The next is MAN. Okay, I'm just skipping WAN as of now. The next is MAN. Now take an example of your TV network. Okay, maybe you have some sort of dish TV, maybe you have some sort of let's say local cable TV. Then they are connected in cities, like in one city they have different branches, they have different network. So a TV network is considered as a MAN network because it is connected across cities or in the city. Okay, so a communication infrastructure that have been developed in around large cities. So if, let's say, I'm talking about a GTPL network which is in Gujarat. Okay, so GTPL is a TV network provider. So they have offices across Gujarat. So if all of their branches are interconnected, okay, along with different cities, then it's considered as a MAN network. Okay, and now we'll focus on WAN network. WAN, as the name suggests, wide area network. So it basically connects two different countries. For example, eSecurify do have office in India, and maybe in future if eSecurify is having offices in Australia, and if we connect both the office, okay, with the help of WAN, then it's considered as a WAN network. because like two different networks across the across the countries are connected, and that's basically wide area network. Also, your internet, okay, www.anything.com is considered under a WAN network. So a network that connects two or more local area networks over a potentially large geographic distance. So that's WAN network, okay. I hope types of network is clear to all of you guys, and this is a diagram of a LAN network. So like WAN network. Here is LAN number 1, here is LAN number 2, and they both are connected across a huge geographic distance, and that's why it's considered as a WAN network. Okay. Now in a network, okay, the first and the very foremost thing which is important is IP address. Okay, you need to understand about IP address, because what connects one device to another device? It is IP address. IP stands for Internet Protocol, and it is a unique number assigned to all the devices that either connects to a network or to an internet or a network. I repeat the definition. It's a very simple definition to make you understand. It is a unique number assigned to all the devices that either connects to internet or a network. So I'll take you an example. I'll give you an example. Let's say a pizza. You ordered a pizza. Okay, you ordered a pizza. So the pizza delivery boy, okay, if he does not know your address, okay, would he be able to deliver the pizza to you? No. He needs your address to be delivered, right? He needs your address for pizzas to be delivered at your doorstep. Similarly, if I do not know your IP address, and if I want to connect to you, I'll not be able to connect you. I don't know where you exist in the virtual world, and that's the reason that in order to connect between between two systems, okay, if I want to connect you, if I want to connect someone else, if I want to connect someone else, okay, or somebody wants to connect me, they need my IP address. If I want to connect you, I need your IP address. So the entire connection game over a network is on IP address, okay. So that's why you need to understand IP address very thoroughly. So it acts as your virtual address with the help of which you can connect and can also be located. Yeah. So if you know someone's IP address, you can connect to them. If someone knows your IP address, you can be located by them, and then you can get connected with them. So that's important, right? Talking about versions of IP address. So there are basically two versions, IP version 4 and IP version 6, okay? IP version 1, 2, 3 and 5 all went into research. Some particular versions failed, some did not go live, but these are the two versions which are live, okay, which we are using in our day-to-day life. IP version 4 is the most widely deployed internet protocol used to connect devices to internet. So as of now, IP version 4 is being used since last around 20-30 years. Yeah, IP version 4 is being used since last 20-30 years, and IP version 6 is the newest version of the IP address, which is now used by a lot of tech giants like Google, Facebook, Amazon to connect their cloud infrastructures, okay. So IP version 4 is a 32-bit number, okay. IPv4 is a 32-bit number, and IPv6 is a 128-bit number. We are going to look into more information in the next slides. So IPv4 is the most widely deployed internet protocol used to connect devices to the internet. IPv4 uses a 32-bit address scheme, allowing for a total of 2 raised to 32 addresses, just over 4 billion addresses, okay. So with the help of IPv4, approximately over 4 billion devices can connect, okay. But still, the number of IP address that we have with the help of IPv4 is less as compared to the total number of devices that we have in the entire world. Understand, the number of IP address that we have with the help of IPv4 is comparatively less than the number of devices that we have in the entire world, and that's why IPv4 is on the verge of exhaustion, okay. It will exhaust very soon. IPv4 will exhaust very soon, and that is why tech giants have started using IPv6 for the cloud infrastructures. If they want to connect their like large cloud infrastructure, they will use IPv6. I'll make you understand why. Okay, so now at this point I hope that you have understood that IPv4 does have a limited IP addresses which are not enough for entire world to connect, right? So with the growth of internet, it is expected that number of unused IPv4 addresses will eventually run out, because every device including computers, smartphones, game consoles that connects to internet requires an address. Okay, so I'll walk you through details of IPv4 first. So as I've told you, IPv4 is a 32-bit number. So it is divided in 4 octets. Okay, so this is octet number 1, octet number 2, octet number 3, octet number 4. Okay, now ideally IPv4, when we say it's a 32-bit number, it's a binary number. Okay, it is a binary number. So okay, so this is basically 8 bits. We can consider this as a 1 byte. Again, second 8 bits, we can consider this as a second byte, and that's why IPv4 is a 4 byte. Okay, like you can convert bit and byte, like 32 bits is equals to 4 bytes, and basically it does have 4 octets. Okay, octet means again 8 bits. So this is the binary version. Okay, this is the binary version, and this is the decimal version. Like every bit over here, okay, every bit over here in 1 octet does have a power. So I'll just explain you what it is. So as I told you that every bit, okay, does have a power. So this is it, like the bit starts from right to left. So this is the first bit, so it does have power 1. Second bit does have power 2. Third bit does have power 4. Not here should be 4, here should be 8, okay, we have I think 9 zeros instead of 4, instead of 8. Yeah, perfect, this is alright. So first bit does have 1 power, second bit does have 2 power, third bit does have 4 power, fourth bit 8 power, fifth bit 16 power, and likewise 8th bit does have 128 power. Okay, so if you make a total of this 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, it gives you a total of 255. Okay, so it means that total number of IP addresses possible in the entire world with the help of IPv4 is 255 into 255 into 255 into 255. Okay, so it's basically multiplication of 255 into 255 into 255 into 255. Okay, and this is the last possible IP address with the help of IPv4. Okay, this 255.255.255.255 is the last possible IP address with the help of IPv4, which is the first IP address 0.0.0.0. Okay, and as you know, there are like going forward, you'll know there are different ranges and different things along with the IP address. But I hope this explains about the basics of IP address. Like it is a 32-bit number, and it's written in usually binary, but we convert it into decimal for our better understanding, and we can write down the decimal IP addresses like 172.16.80.25 or 22, something like this. Okay, so this is a decimal representation because we cannot remember the binary numbers. Okay, can you remember the string of 32 bits with zeros and ones only? No, right? So we have converted into decimal, and this is what we can remember. Okay, it's still hard. If there are a lot of IP addresses, it's still hard to remember these numbers, but at least if there are a few IP addresses which are your own, you can still remember it. Okay, and it's easy to pass on, it's easy to read, it's easy to understand. So that's why we convert a normal IP address into decimal version, and that's particularly fine. Let me quickly go back to the slide. So here we have 172, 16, 254 and 1. So this is the entire IP address. Okay, 172.16.254.1 is the entire IP address. So if we want to make 172 in binary, how can we make it? So it's simple. If we want to make 172 into binary, okay, so basically, okay, let's do it over here only. Let's do it over here. Basically we have to turn 128 1. Okay, see, 0 means bit is off and 1 means bit is on. So if I do 1, now the entire value of this binary number is 128, because this bit is on and it does hold a power of 128. So 128 plus we will require, like, plus we will require 44, okay, to make 172. So we will enable 32, we will enable 8, and we will enable 4. So now you can see 128 plus 32, it gives you 160, plus 8 it gives you 168, and plus 1, I mean plus 4, it gives you 172. So this is equals to 172. Okay, so likewise you can create the entire IP address in binary, or you can understand the binary now into and convert it into decimal also. So let's go to next slide. Now IPv6 is a 128-bit number. Okay, it's also called as IPNG. It's Internet Protocol Next Generation, and it looks like this. It's a hexadecimal format. Okay, it's in a hexadecimal format, and it does have 16-bit of hexadecimal in form of 8 groups. So this is group number 1, this is group number 2, this is group number 3, likewise 4, 5, 6, 7, 8. So these are 8 groups, and all they are connected with a colon sign. Okay, here we don't have a dot, here we have a colon. So if you can see, this hexadecimal representation is very difficult to read and understand, and that's why we have not started using IPv6 in our day-to-day purposes. Only the tech giants are using IPv6 for now for setting up their cloud infrastructure. Okay, so basically where you don't require IP addresses to be remembered, you are using IPv6. Okay, because in cloud infrastructure it's okay if we do not remember the IP version, IP address of all the cloud servers and everything. Okay, because it is already configured. But for a web application, for something like IP camera, okay, we cannot have this IPv6 because we cannot remember such IP addresses. So it's still not user friendly as of now, and research is still going on how we can use IPv6 effectively. Okay, so of course this IPv6 is publicly out, and tech giants are using it. Now as you can see, leading zeros can be removed. Okay, so here we have removed 0, here we have removed 2 zeros because they are leading zeros. Also all the zeros which comes in between, okay, all the zeros which comes in between can be avoided as well. So we can just put double colons over here, and then we can remove these multiple groups of zeros. So as you can see, double colon is equals to all zeros in one or more group of 16-bit hexadecimal numbers. Okay, so this is what IPv6 is. Now we'll understand about static IP address and dynamic IP address. So these are basically allocation schemes. Okay, we can also consider it as a type of IP addressing, how IP addresses are given. Okay, so I'll give you a very nice example. For example, we have one point of connection. Okay, of course, like at our home or office we have one point of internet connection mostly. So when I say one point of internet connection, as in only one line of internet connection, right? Your ISP gives you one cable of internet, and you plug into your router, and then you connect all your devices to that router to access internet in all the devices. So from ISP, that is internet service provider, you're only getting one point of internet connection, but then you're splitting the connections and you are using across multiple devices. So now router, okay, when you have a Wi-Fi router, it does all this private networking. It does this private networking, and it gives you the IP address in your multiple devices that you connect to router. Now router can provide IP addresses in two ways: statically or dynamically. So when I say static, your IP address will remain as it is, okay? Or let's say you will have to assign, like let's say if there is any network administrator, okay, then a network administrator will have to give out a particular IP address to a particular person. Now this is useful in kind of, let's say, a banking environment. For in a bank, if a network administrator gives out a static IP address to each and every of the banking employee, okay, or a banking staff member, then it is easy for a network administrator to trace out what has gone wrong in which in whose computer, and like whether any attack is being done with the help of any computer or not, okay. So it's easy to trace out any malicious activities with the help of static IP, and we can easily locate the user, because that IP is only given to that particular user. So we can maintain the logs accordingly very easily. When we give out dynamic IP address, so in case of a dynamic addressing, again it's very easy to configure, because if I set dynamic IP address allocation, that's with the help of DHCP, okay, dynamic host configuration protocol, or bootp. So I'll talk about DHCP for now. If I add dynamic IP addressing, then I don't have to do anything being a network administrator, okay. Router will do the job accordingly. If you connect, router will provide you an IP address. If somebody else connect, then router will give out the IP address to them as well automatically, okay. Do not have to do anything. So that's dynamic IP addressing. Now in static IP addressing, your IP will remain constant. In dynamic IP addressing, your IP will change continuously, okay. Continuously as in like let's say if you are connected to the Wi-Fi network, then you get disconnect for some time, maybe for a few seconds, then again you connect back, okay. So maybe your IP address gets changed based on the lease time, okay. So that's basically dynamic IP address allocation. Now I'll give you a very nice example again to make you understand about dynamic IP addressing, why on a global level we use dynamic IP addressing also. So as you know, with the help of IPv4, we have a very less number of IP addresses as compared to the number of devices that we have in the world that connects to internet, okay. So in order to prevent the wastage of IP addresses, okay, IPv4, we can use dynamic IP addressing on a global level, on a public level. For example, you turn on your mobile data, you get one IP address, and you are able to surf internet, okay. So when you turn off, your IP address goes back to the server pool, and that IP address will be allocated to someone else if someone else is turning on the mobile data. So that's basically reusing the IP addresses, and we are not wasting the IP address, because being a normal user, we are only concerned about having internet in our mobile phone or a device. We are not concerned about having a particularly a static IP address, okay. So that's what we can do with the help of dynamic IP addressing. And like see, sometimes we also need static IP address, okay. So for hosting the websites, for setting up IP camera, for setting up CCTV camera, for setting up video conferencing solutions, maybe a lot of other solutions, okay. So we need a static IP address. So static IP addresses cost us, okay. It does not give, I mean, it's not for free. You have to explicitly request a static IP address, and then you will get it. So in that case, your IP address will remain constant, no matter you log in, you log out, okay. So maybe you disconnect from your internet and maybe you join back again. If you will check, your IP address will be same in case of static. In case of dynamic, your IP address will change. So do this exercise, okay, for dynamic IP addressing. Like turn on your mobile data, go to google.com and type my space IP, okay. Check your IP address, note it down, then turn off your mobile data for few seconds. Again, turn on your mobile data, go to Google, and again type my space IP and check the IP address. It will be changed, okay. The reason is all the mobile mobile telecom providers, they do give us dynamic IP addressing, all right, because we want to prevent wastage of this IP addresses, okay. I hope this explains well about static IP and dynamic IP. And then we have classes of IP address. So we have 5 class A, B, C, D, and E. Class A is for large scale network, class B is for medium scale network, and class C is for small scale network. Class D is for multicasting, and class E is for experiment and research. So practically we only use three classes, class A, B and C. Okay, so class A starts from 1 to 126. Look at only the initials, okay, 1 to 126, because like the further octets, okay, will be from zeros to 255. Only look at the first bit. 1 to 126 is the range of class A IP address. Then 128 to 191 is the range of class B IP address. 192 to 223 is the range of class C IP address. 224 to 239 is the range of class D IP address, and 240 to 255 is the range of class E IP address. So we practically use class A, B and C. So if you ever get the IP address like which starts from 82 dot something dot something dot something, you have to understand that this is a class A IP address. If you ever get IP address like 135 dot something dot something, you have to understand that this is a class B IP address. Likewise, these are different ranges and you should be understanding this. Okay, now as I've told, yeah, that class A is for large scale network, class B is for medium scale network, and class C is for small scale network. Okay, how exactly? I'll just make you understand. Yeah, we have classes over here. So I want you to understand about subnetting, like not subnetting as of now, but subnet mask. Yes, subnet mask. So for class A, subnet mask is for class A, subnet mask is 255.0.0.0. Okay, so this subnet mask is of this pattern, n.h.h.h, where n is equals to network bit and h is equals to host bit. Okay, so this means that with the help of class A, we can create 255 networks. We can create 255 networks, yeah, and with help of class A, we can connect 255 into 255 into 255 hosts per each network. Okay, so that's why we can create a bigger network with class A. This is for large scale networking. Okay, only 255 networks can be created, but in all the 255 networks we can connect 255 into 255 into 255 hosts. So that's why class A is for large scale network. Class B, subnet mask is 255.255.0.0, and this resembles to this pattern n.n.h.h. So we have 255 into 255 networks and 255 into 255 hosts for each network. Okay, so this is why class B is for medium scale organization or medium scale networking. Class C, we have subnet mask as 255.255.255.0. This resembles to pattern n.n.h. Okay, so we can create 255 into 255 into 255 networks, and for each network we can connect 255 hosts. So as you can see, in class C we can only have maximum of 255 systems getting connected. That's a small scale network, right? Also, always 0 is reserved for network address, and 255 is also reserved for broadcasting. Okay, so practically we cannot use the first and the last address. Okay, we can only have access to this 254. In class C we can only connect 254 systems, because first 0 and last 255 is reserved for different purposes like network address is and to broadcasting. This is for all. Okay, this is for class A, B and C everywhere. First bit is always reserved for network address, last bit is always reserved for broadcasting. So yeah, you just need to understand this. I hope this explains well about classes of IP address. Then we have private IP address and public IP address. So like you are connected into some Wi-Fi network, okay, at your home or college or maybe your office. Then if you go to this command prompt and type down ipconfig, you will get your IP address like this: 192.168.0 dot something or 1 dot something, okay. But most probably it will start from 192.168 if you are in a small scale network, okay. But because this is a class C IP address which we recently understood, so my home router is of course having a very less number of connections, and that's why falls under class C networking, and that's why we are getting a class C IP address over here, okay. So this is my private IP address, understand, because uh, for all the three classes, for class A, for class B, and for class C, okay, we have a reserved range for private addresses, okay. These are all private addresses, private IP addresses, okay. These are all the reserved ranges for class A, B, and C. See, 10, okay, 10 falls between 1 to 126, so this range is for class A private IP addressing. 172 falls between 128 to 191, so this is for class B private IP addressing. And 192 falls in class C, and that is why this is for private IP addressing of class C, okay. Why do we have this private IP addresses reserved? For local networking purpose, okay, for local networking purpose. So that's why we have this particular IP addresses reserved. So as you can see, we can check the private IP address from the command prompt like this. And now if I go to Google and if I type MySpace IP, okay, MySpace IP like this, we will get our public IP address. So my public IP address is different from my private IP address, because my public IP address is that IP address which is provided by my ISP, okay, to my router. Like my ISP has provided one connection, okay, and that connection I have just plugged into my router. So the IP addresses which is with my router is this, my public IP address, okay, and the IP address which router has given to me, okay, is this private IP address, okay. So I hope this explains well about private and public IP address. Let's go back to the module. Yeah, now public IP address could be static or dynamic, okay, because I have a normal Wi-Fi connectivity, so I don't have any specific static IP address requirement. So what will happen, like if I switch off my router, okay, if I completely switch off my router, and then after a few seconds if I switch it on, my public IP address will be changed, because my existing IP address, my public IP address, will go back to the server pool, and then server will provide that IP address to someone else, because it's free, okay, I'm not using it, I have turned off my router. Then again if I turn on my router, ISP will provide me a new IP address which is available in the server pool, and that's why it keeps on changing, okay. But it will not change for a particular number of hours, mostly around 24 hours, okay, if the router is continuously on. If the router is continuously on for 24 hours, okay, then IP address will not change in between. But if you turn off your router completely, okay, then the IP address will be changed. So public IP address can also be dynamic. So that's just I wanted to tell you. Next concept is network address translation. So this is also a nice concept. Like as you know that we have one point of internet connectivity from the ISP, and then we all are using internet with the help of router. So router does all the wireless networking, okay. But router has this process. Router is having this process in the background which is called as network address translation. So the request goes from the private IP to router. Router have a routing table, okay, and in routing table router manages that this request is coming from this private IP and is requesting for this resource, okay. Then router will send that request to the external world, okay, with the help of public IP. So it communicates in the external world. Then the response will be back to the router, okay. the request that you have made, okay, is being sent by the router to the external world, and the response will be back to the router, not to you directly. And then router will check that, okay, this is the response for this request, and this request was made by this particular private IP address, and let's send the response to this particular private IP address. Okay, so that's how the entire process works. It's called as network address translation, with the help of a routing table as well. Okay, so it will never happen like you request something and your friend will receive it. Okay, it will never happen, because router does this network address translation, and it manages the routing table as well. So yeah, this is what the same thing in the diagram. We have multiple systems connected under one router. Consider this as a router, because nowadays we don't have explicit NAT server. We have this in the router itself, or the other devices like switch and other things. Okay, then this is the public IP address which ISP provides, and with the help of which we can access the internet. So if you request anything to the external world, this response will be prepared through internet, and it will be sent back to the router. Then it's the job of router to send the response back to you, looking at the routing table. Okay, so this is being managed by network address translation and the routing table. So I hope this explains well about that. Next is domain name system. Now like as the name suggests, domain name system. Okay, so it is basically used to map the domain name with the IP address. We cannot remember 10 like 100 of IP addresses at the same time, right? You cannot even remember 10 IP address, but so it's always easy to remember names than numbers, right? So we have to map. We usually map the IP address with the domain name, or vice versa. We map the domain name with the IP address. Okay, so my website is running on a server. So basically my website is running on a server which does have an IP address. So but I cannot remember the IP address of my website for a longer period of time, or my users will not find it friendly to open up my IP address every time. Instead, if I have some domain name esecurify.com, they will be easily remembering it, and they will be opening it, right? So I have to map my domain name with the IP address. That is what the DNS is. So yeah, these are different lookup sequence. Okay, like let's say if you are entering amazon.com, then it will be checked in your hosts file. It will be checked in your hosts file. We have hosts file in our system, be it Windows, be it Linux, okay, or be it MacBook. So this host file does have an entry. Okay, like this is the IP address, this is the domain name, this is the IP address, this is the domain name. Okay, likewise host file does have an entry. So it will go and check whether there is any IP address for amazon.com or not in the host file. If there is any IP address for amazon.com, it will open up that IP address. Okay, it will open up that IP address, even though that IP address is not of Amazon. Understand, as you have mentioned it in the host file that for amazon.com open up this IP address, then if you type down amazon.com in your browser, it will open up your IP address even though it is not amazon.com. Okay, so this is lookup sequence. Okay, DNS lookup sequence. First lookup is in host file, second lookup is in browser DNS. In browser also we have DNS setting. So if we have mentioned any IP address over there for DNS server, it will query DNS server, and it will see whether there is any IP address associated with amazon.com or not. If it is associated, it will open up that IP address. If it is not associated, it will go to router DNS. Okay, so this is the entire sequence, right? First of all, the request is in the system, so it will be checked in the host file. Then the request will go out of browser, so it will check in the browser. So then from browser it will go to router, so it will be checked in router for DNS. Again, if the DNS is not set for amazon.com in the router, it will be going to ISP. Okay, and in ISP, if Amazon's IP address is not there, it will go and finally check in the Google DNS, because Google have everything. So this is the lookup sequence. Okay, looking up for a IP address for a specific domain when you enter any particular URL in your address bar. Okay, so yeah, this is what domain name system is, which you need to understand for now. Then we have ports. So this is again really important to understand. we have ports in our computer system. Basically we have two type of ports: hardware ports, which we call as a physical ports, and software ports, which we call as a virtual ports. So hardware ports are like USB, HDMI port, Ethernet port, SD card, audio, and software ports are not like this. Okay, these are not just few, but it ranges from 0 to 65535 ports. Yes, we have 65535 virtual ports in our computer system. And just as the IP address identifies the computer, right, with the help of IP address we can locate someone, we can connect to someone. So similarly, the ports do run some applications or services. Understand the, like, why we have built computer? Because we want to do multitasking, right? So it's not like on one IP address we will do only one job. On one IP address we can do 65535 job. Understand? Because we have 65535 ports, and that is what the capacity of computer is. Okay, on a single IP address we can run 65535 jobs. Every port does have some kind of service or application running. Of course there are a lot of ports which are idle, which are not used by the applications, so they remain idle. But we have some well-known ports, we have some registered ports, okay, which are commonly used. So yeah, on each and every port we have some services or application running, and that's why we can do like we can do multitasking with the help of computers. Okay, so if you have a question like what exactly port is, so it's a 16-bit unsigned number and is identified for each transport protocol. So basically we have two transport protocol, TCP and UDP. So TCP is it's transmission control protocol. Yes, it's transmission control protocol, and UDP is user datagram protocol. So TCP is basically connection oriented protocol and UDP is connectionless protocol. So for TCP we have to establish a connection, and for UDP the connection is not required. Okay, I'm not talking about an internet connection, but connecting to ports for communication. So this is basically TCP. These are different common ports of TCP. These are different common ports of UDP. Okay, so FTP we have 20 and 21. FTP 20 is for data, 21 is for file transfer. Then SSH 22, Telnet 23, SMTP 25. These are some common ports, right? You have to I can say mug up, because this will be useful. This will be useful going forward. Okay, so that's it with this video. I hope you have liked this video and enjoyed watching this. So make sure you watch out this again if you have missed out anything, and make sure you understand each and every concept clearly. Alright, so thank you for watching once again. See you in the next video.